This brief demonstration will highlight new Bigtable features that streamline real-time analytics and facilitate immediate operations on high-volume telemetry and time series data. For this demonstration, we'll utilize a publicly accessible automotive telemetrics dataset, which has been reconfigured into the Bigtable data model. Let's start by looking at what this data looks like once it lands in Bigtable's flexible schema. This is Bigtable Studio, the Bigtable user interface for browsing and querying your Bigtable data. The vehicle telemetry data that you see here contains the data we're going to be working with for the demo. Under the table, you're going to see column families, which is how Bigtable structures your grouping of dynamic columns. If I run an example query against this table, you can start to see what this data looks like. And let me make this a little larger. So if I start here, we store each of it's got 3 devices. And the sensor information is being collected for each individual device. But the sensor information, because it's collected in a flexible schema, may actually change across the different rows. Now, it's important to understand this is not simply a blob of text where the database would need to process an entire chunk of bytes with each read or write. Each of these fields is what Bigtable refers to as a column qualifier. And these can all be read or updated individually, and that greatly reduces the amount of data that you have to process when you're looking for specific information. And so, while you're only looking at 3 rows of data here, if I flip that identifier to true, you can see that Bigtable has actually retained an entire version history over time. Now, one more element you might see here, might have noticed as we were playing with the data here. These counters. These are aggregate column families that collect right-time aggregations for our vehicles, giving us an immediate look at the vehicle's odometer reading and tracking how many miles are needed before maintenance is required. Now in this demo, we're only updating aggregations for 3 vehicles, but these aggregation column families, or counter data types, are conflict-free replication data types that are optimized for incremental updates and can handle millions of QPS and merge writes from across the globe without locking records. Now that we understand a little bit more about the Bigtable data model, let's see how we can take automated actions on this data using a combination of Bigtable's continuous materialized views and the agent development kit. I've already configured this continuous materialized view to track vehicles requiring maintenance. The view's definition reveals the language used to extract the structure with the flexible schema is just straightforward SQL. It's the same dialect used by BigQuery. Now when this continuous materialized view is created based on this query, each of the new records are going to get processed incrementally according to these rules as a low priority job, with the result written as a data copy. So that's not a batch process, but rather that's a record by record update. Now within this SQL, the map types here are used to locate and parse geolocation data, and we're specifying a filter for the buses that are actually going to be requiring maintenance in. So I can go ahead and just query that view directly. And filtering this data here into a dedicated materialized view, it's going to streamline our process for downstream applications, enabling them to pick up easily just the only relevant information and records that they need. And if there's any updates or deletions that occurs to the underlying table, for instance, if that maintenance counter gets updated or reset, the materialized view is going to accurately reflect that information. Let's now flip over to a cloud workstation and look at the agent development kit to understand how you can integrate with the Bigtable materialized view into an agentic application. We're going to be using the agent development kit, or ADK, which is a flexible and modular framework for developing and deploying AI agents. It's optimized for Gemini and the Google ecosystem, but it's also model agnostic, deployment agnostic, and it's built for compatibility with other frameworks. So if I take a look at this agent file, and that's just part of a standard ADK development, this is where I'm going to give the LLM specific instructions about what this agent is designed to do. I'm also going to hook it into a tool set, and you can notice that there's some Google provided tools out of the box that I can give it, including this Bigtable tool set. And if you take a look, where Bigtable is directly integrated with the ADK framework, and I can start to load up these tools, and it'll help me with just basic things like handing over credentials, as well as just creating basic agents. So I can do things like quickly just give it a SQL statement and have it know how to go and best execute that SQL query. This tool that I've developed here is just pulling all of the data from that maintenance view that we created. So I'm going to go ahead and just to show you how this works, I'll go ahead and start the ADK web browser, which is a way we can start to interact with these agents and see what it's actually doing. So I'll go ahead and open this. And now this is the agent toolkit, and I can start to ask, what buses need repair? And so it actually went out to Bigtable. It recognized that it needed to use that tool, and it found the bus that needed repair. And if you notice, it also identified the city associated with those geographic coordinates. Now, I didn't have to give it like some Google API calls or anything like that. I just asked the LLM to always return the city information along with that. And now I can start to integrate this agent with other agents. So I also have a little Python agent that I wrote that says, notify the driver of repairs. And then this can go out and actually notify the driver and gave it some maintenance locations near where he is. And if you can take a look, this is a agent development kit. It has a nice way where you can start to review exactly what is happening. The agent recognized I needed to call this search agent kit that's based on Bigtable data, and I can start to go look at these calls and even look at the responses that came back from the database, how it authenticated. You can see this is the actual line of data that was returned from our Bigtable materialized view. All right, so now that we understand how to integrate Bigtable into our operational AI workflows, let's take a look at how Bigtable can also be used for offline and real-time analytics. Bigtable has a disaggregated storage and compute model, so that older data that's not needed for live application traffic anymore can automatically be tiered based on time to a cost-effective analytics storage. We can use a serverless compute layer called Data Boost to give us direct access to that underlying storage. Now, this Data Boost offline compute service is isolated from the serving traffic and can be used from BigQuery Studio, so data analysts and data scientists can run their high throughput scans on that data and not worry about impacting any of the production applications. So back in Bigtable, let's once again look at our vehicle telemetry table. And let's say we want to do a time series analysis on the battery life history. That historical data format, while it's efficient for applications, it's not always ideal for data analysis. So to facilitate time series analysis, we'll leverage a specialized Bigtable SQL function called onPack. This function is going to transform our time series data into a row-based structure, which is more conventional format for such time series analysis. And so you can see what that looks like here, where it's row by row. So I can go ahead and create a logical view based on this battery information and the onPack function. And unlike a continuous materialized view, a logical view simply abstracts away that query, but it does not create a copy of the table. So the logical views let me structure this flexible schema into a schema that traditional analytics tools can use, and I can give the data analyst who need access to that data permission read only from that view. I also can go ahead and create an application profile for analytics users to leverage Data Boost. So as a BigQuery user, I can now access this view from a Python notebook in BigQuery Studio. This is just boilerplate Python setup, and essentially what I'm doing is just calling this select star from that view that was created for me, and I can quickly just turn that into a pandas data frame. And once it's there, I can start to use BigQuery Studio to actually generate some basic visualizations on what's happening with my Bigtable data. And so it does a guess and knows that I want to look at data in a time series, but maybe I can make a modification here and actually look at it by average instead of sum. And I might see some, and there's lots of other charts I could choose from as well, but maybe I notice an interesting trend here with this visualization. And so I can go ahead and maybe I'll schedule this notebook for recurring updates to see what's going on with the Bigtable data, or I could share a link with somebody in my organization or share it. And what that will let me do is I can go to the development team and say, hey, you might want to consider making this a real-time dashboard. Again, we can use the continuous materialized views feature in Bigtable to create this essentially updating average of battery power and we can keep this up to date in seconds with the materialized view. So let's go ahead and turn that SQL statement into a materialized view. Hopefully this demo showed you a little bit about how Bigtable is a really powerful solution for high volume telemetry and time series data, and it enables both real-time operational AI workflows with continuous materialized views and the agent development kit, but also scalable historical analytics through logical views and data boost, along with integrations with tools like BigQuery Studio. Thanks for watching.